Okay, going over the homework. We are doing number 5 on the front page. Is that right? Kyle, you're talking about the one that says f of x equals the square root of x? And f of x equals the negative square root of x, right? Well, all it wants to know is what happens from the square root of x to the negative square root of x? It flips upside down. Remember, you have this graph. And f of x equals the square root of x looks like that, right? So if you put a negative in front of it, like the second one, it just turns around and it goes like that, flips over the x-axis. And all you have to do is say reflects over the x-axis. Okay? Yep, that's a reflection. To reflect over the x-axis, you put it on the outside. Well, you guys, but these right here I would have liked you to graph. I kind of give you the choice. I give you the choice on those first 8. I hoped you put it in your calculator so you understood for sure that you got it right. Okay? Okay. All right. I said you don't have to. Okay. Any other questions? Okay. What's the difference between, okay, number 6 is also a reflection. But this time, the negative is inside the function, right? We replaced x with negative x. Okay? If you make a graph of these, f of x once again looks like that. What happened when you guys put an x inside the function? What did it do? Okay, Dietrich, what did you say? Yeah, it reflects it over the y-axis. It goes this way. If you just flip it over the y-axis, that's what you would get on number 6. Yeah, square root of negative x. Put the negative x inside the function. Is that what happened? Well, let me see if you're probably not doing it right. Let's go right here, and you'd the square root of x and the square root of negative x inside the parentheses like that. You graph it. The first one looks like that. The second one looks like that. Got it? I don't know, 10 to 12 questions on the quiz. Okay? 10 to 12 questions. The thing is, you got to remember, it counts as half your grade. You might be getting an A here, but if you flunk that, you'll be getting a D or a C. Depends on how bad you flunked it. You might even be getting an F. Okay? Everything since the quarter began. So it's been on the last 5 lessons or so. You can go back and look at the notes that we took on it that are on you can go look at your notes, but I look around and it doesn't seem like very many of you guys are taking notes. Okay? I watch some of you guys when we're doing notes. There's about 10 of you taking notes, and the rest of you guys just sit there. And then you don't even listen. And you're trying to go off memory, and you guys probably won't remember it. I wouldn't remember it. I have to review it. Okay, so you have to go over it and over it again. Okay, are there any other questions? Okay, these are called absolute values. Okay, if you go right here, this is you guys are talking about number 3. And, thank you, Jax. Okay, and if the calculator, my calculator doesn't make them, some of your calculator, it's absolute value. You hit the math button, you go over to number, and the very first one says absolute value. You hit enter, and paste it back to your y equals screen. Y equals screen when you started. Okay, and then you can type in whatever you're doing, like -2 is one of them. So -2, and you close the parentheses. And that's supposed to mean absolute value. How many of your calculators are actually putting absolute value signs? Yeah, with the double lines around it, instead of putting ABS when you put it in. Raise your hand high if your calculator does that. Okay. Some of the calculators are doing that, and some of them are not. I know I got some newer versions, and that's probably the newer versions are doing that. I actually like that better. But the ABS is what most of yours are doing. Okay? So now when there's the function. Okay? All right, any other questions on the homework assignment? SM2 block says pre-calculus. Okay. That's secondary math 2 block is yours. Okay, how many of you guys got number 8 on the back side? 2 of you? 3 of you? 5 of you? Number 8 on the back side, the W-looking one. I told you yesterday it was a composition of 2 functions. What is or it's one function put inside of another one. What does come up with? How many? Absolute value of what? Okay. I want to just graph x minus 4 first, guys. X squared minus 4 is this parabola. Now, if I take the absolute value of x squared minus 4, the whole thing, what it does is it makes it so that when I take positive, right? And so see all the values down here? So I'm going to outline it. All these right down here. Those are negative y values. So if we take the absolute value of those, okay, so if we go back in here, and up there, instead I go math, number, absolute value, 4, and I take the absolute value of that function. What it does is it just takes all those x values, those y values that were negative, and it makes them positive. You see that? In other words, it flips it up over the x-axis. Erase that so you can see it. Got it? Just make that bottom part of it, and it flips over the x-axis. Any questions there? Okay. Any more questions? Natalie? Okay. Backside? Okay. 7 is what kind of function? It's what? I'm going to go back to this. It's not exponential. It's what we call a reciprocal function. F of x equals 1 over x. It's that reciprocal function. Now, if I graph that, if I was to graph this, it looks like this. 2 parts to it. And it looks something like that. And you'll notice right here in the middle, where the 0, 0 is, it's kind of like the middle point or the focal point between those 2 parts. You see that? That's the part we're going to shift. Well, which way did that thing shift? If you look at the focal point now, which way did it shift? To the left, 4, and Well, if you look right at the focal point, it looks like it's probably at -4. Because it goes -2, -4, -6, -8. If you were to draw right down the middle of those two, it would probably go right through -4. And so, and then which way it shifted up and down? Which way did it shift? Down a little bit. So if I was to put this in my calculator, first of all, y equals 1, how do I get it to shift to the left 4 units? I replace x with x plus 4. So it has to be in the bottom of the fraction. How do I get it to shift down 1 unit? I minus 1 from the whole function. Because remember, shifts left and right, horizontal shifts, you have to replace x with x plus something or x minus something. To shift it up or down, you subtract it from the whole function. So horizontal shifts are inside the function, vertical shifts are outside the function. So I graph this. 1 divided by x plus 4. Notice I had to put the x plus 4 in parentheses on the bottom there. And I minus 1. I graph that. That's the graph that you see right there. Okay? That is actually it right there. Any other questions? Okay, now we're going to correct it. So, okay, the objective, first of all, you guys, is over here on the whiteboard. Determine whether or not a function has an inverse. That's one of the first things we're going to learn is, well, we're going to first learn what an inverse is, and then we're going to be able to tell whether a function has an inverse or not. And then we're going to be able to find the inverse if it exists. So by the time you're done, you're going to be able to tell whether a function has an inverse, and if it does, you're going to be able to figure out how to find it. And then you're going to be able to understand how to restrict the domain of a quadratic function so that it has an inverse. I'm not so worried about the second part of that until we get to it. Okay? You've got to learn the first part to understand what the second part is saying. Okay, now, this is right here on the smartboard is the definition of inverse relations. Remember you guys learned about relations and functions? A relation is just a graph or an equation, okay? But it might not be a function. Most graphs, well, not, some graphs and some relations are functions as well. Okay, but right here, two relations are inverse relations if and only if one relation contains the element b comma a whenever the other relation contains element a comma b. Let me show you what that means. If you make an XY table, and let's say you had in your table 1, 3, 7 for the X numbers, and for the Y numbers we had 5, 2, and 8. Okay, let's say that that's our relation. Well, the inverse can be found by doing what? According to this definition, what is it saying I'm going to do? I'm going to switch them, right? I'm going to switch the x and y. And so instead of 1 comma 5, what is it going to be? 5 comma 1. Instead of 3 comma 2, it's going to be 2 comma 3. Instead of 7 comma 8, it's going to be 8 comma 7. That's what an inverse is. You switch the x and y coordinates. Could you guys all tell your shoulder partner? If I asked you to, would you be able to tell your shoulder partner what an inverse is? Yes, sir. Okay. I want the person on the left to tell the person on the right what an inverse is. Go. What an inverse is. All right. Okay, now look up here. If f of x denotes a function, then f inverse of x denotes the inverse of f of x. I don't know why, like 300 years ago, some mathematician decided that the way we're going to symbolically represent an inverse is by doing this little f to the negative 1 thing right here. This thing right here. See it? I think it's a bad way to represent it. You know why? Because what does it look like? What does that negative 1 look like? It looks like an exponent, doesn't it? Okay? But it's not. This is not an exponent. You can't think of inverses as exponents. Okay? That right there is just the symbol for stating that a function is an inverse of another function. So if I have a function f inverse, or f to the negative 1, is the inverse. Okay, I want you guys to teach you how to say this right here. So everybody repeat after me. F inverse of x. Say it again. F inverse of x. Okay, that's how you say that. Yep, the negative 1 means inverse. Everybody write down, the negative 1 means inverse. F inverse of x. It says f inverse of x. It's a negative 1, but it means inverse. So that little negative 1 means inverse. Got it? That's the symbol. It's not an exponent. I think the mathematician that came up with this, whoever it was, could have come up with a better symbol. But that's the one they came up with. Now you can stop repeating me. Thanks. What? To tell the time. Yeah, like 198 divided by 6. What do you think that is? 3. 3 o'clock. Right? So that's all their answers. They are. Well, you already know what they say.
Well, I know they do. I was like checking them, but
You can check them to see if they're right. All right, you guys, write this down. The inverse may not always be a function. The inverse may not always be a function. I'm going to go to a different slide, so hurry and write that down. The inverse may not always be a function. The inverse may not always be a function. Let me give you an example, okay, of some that are functions and some that are not. Do you guys remember what the vertical line test is? To see if what? How many of you guys remember hearing it before? Okay. This is what the vertical line test said. It was to test to see if a relation was a function. Okay? If a vertical line, any vertical line you put, only passes through the function once, no matter where you put it, you can put a vertical line anywhere, but only passes through it once, then it's a function. Is this one a function? Yeah, any vertical line you put on here is only going to cross through it once. Got it? Well, let's look at a parabola. Is a parabola yeah, any vertical line you put through it past the vertical test? Yeah. So any function, any relation that a vertical line will only go through it once is a function. Give me some examples that are not functions. How about a circle? A circle is not a function, right? Because if you put a vertical line through it, it can cross through it more than once, right? Okay, we'll go through it twice. a sideways parabola like this. Doesn't pass the vertical line test, so it's not a function. Okay? Do we got that? A rational would be a function. Let's look at a rational. Because a rational looks like this. I didn't draw that very well. Should be more like that. A rational, you guys, no matter where you put a vertical line, it goes through it only once. These two parts right here are going to get closer and closer to that x-axis, but they'll never touch it. So any vertical line is only going to cross through it one time. Okay? Got it? Okay, so here's the deal. What we want to know is, does a function, function have an inverse? Well, the answer is some do and some don't. And this is how you can tell. You're going to do a horizontal line test. That's kind of the same as a vertical line test. If you can make a horizontal line go through it, and it only crosses once any horizontal line, then it's the function has an inverse. Got that, Lacey? So does this one have an inverse? Yeah, because every horizontal line is only going to go through it once. What about a quadratic function? Okay, no, because all those horizontal lines are going to pass through it more than once. You guys, everybody write this down. A quadratic function does not have an inverse. A quadratic function does not have an inverse. Write that down. A quadratic function does not have an inverse. Unless. Everybody write unless. Unless. A quadratic function does not have an inverse. Unless. Unless what? Unless you only take half of it. If you only take half of a parabola, then does it pass the horizontal line test? See, right here, you guys? I did only half the parabola. Now will it pass the horizontal line test? Yes. Okay, that's called restricting the domain. That's half of a parabola. See? If you have a parabola, it's like this, right? You're only going to take from here over this way. If it's half of a parabola, right from the vertex, then it will pass the horizontal line test, and it will have an inverse. You guys, what happens when you take an inverse? It flips it sideways. So, whoops, I didn't draw that very well. Let me draw that again. It flips it sideways, and it goes like this. And now that one's gonna pass the vertical line test, right? Okay. I wanna do an example. Yes. Well, all the functions, you guys, I'm going to give you only functions. So they already passed the vertical line test, okay? So all the problems I give you guys are going to be functions already. They'll already pass the vertical line test. If they pass the horizontal line test, then the inverse is a function. Yeah. Can only go through it one time. Okay. Watch this right here. I want you guys to all graph this. Everybody graph the point -4, 2. -4, 2. Then graph the point -2, 4. Then graph the point 1, 5. And then graph the point 3, 10. and connect them like this. Okay, connect those points. Yes. Good. Okay. All right. Do we have all those? Now, what I want to know is can we how can we get the inverse of this? What are we going to have to do? Switch the what around? Switch the points around. Raiden said it right. Yes.
Like when you switch negative 4, 2,
To what?
like does it become negative 2, 4, or
No, just switch the 2 comma negative 4. Everybody, you just switch you don't switch whatever sign they are. So if we switch negative 4 comma 2, it becomes what, everybody? 2, negative 4. So we go to the right 2 and down 1, 2, 3, 4. We put a point right here. At 2 comma negative 4. What does this one become, you guys? 4 comma negative 2. 1, 2, 3, 4. 1, 2. 4 comma negative 2. We got that? Yeah, all you put in, right? No. No. We got to do more. Instead of 1 comma 5, what is it going to be, you guys? 1, 2, 3, 4, 5 comma 1. And instead of 3 comma 10, what is it going to be? 10 comma 3. And I connect them. Does anybody notice anything about those two graphs?
They're all switched exactly.
Switched exactly. I like that. What else? They're reflections. Oh, I couldn't hear you. Okay, they are reflections, you guys, over this line right here. This diagonal line. They are reflections over this line right here, the diagonal line. We call that line, the equation of that line is y equals x. As a slope of 1, it goes through 0 comma 0. That's the line y equals x. You guys, inverses are reflections over the line y equals x. Got it? Okay. And look right here. To graph an inverse, you switch the x and y coordinates. Did everybody write that down? Write it down. To graph an inverse, you switch the x and y coordinates. And the graphs are symmetric with each other over the line y equals x. So write those down. To graph an inverse, you switch the x and y coordinates. The graphs are symmetric with each other over the line y equals x. Yeah? Except for there they are. To graph x and y coordinates, the graphs are symmetric with each other over the line y equals x. You've got to quickly write those.
I know, I'm almost done. Hold on. Y equals x. Okay, I'm done. Whoa.
What I'm going to do now is teach you guys.
You mean inverse relation algebbraically.
Okay, this is what we're doing today, you guys, right here. Everything was just an introduction to what we're doing. Okay? So here's what we're doing. F of x equals 2. Find the inverse. Okay, I'm gonna show you 4 steps to do this, you guys. 4 steps to do this. Quite simple steps. Then we're gonna do a sage and scribe. You guys are gonna teach each other. Okay, but I'm going to teach you once. So pay attention so when you go to teach your partner, you know what to teach them. Okay? So, to find the inverse, step 1 is we're going to change f of x to y. So everybody, we're going to write this as y equals x minus. Okay? Is f of x and y the same thing, you guys? Yeah, it's the same thing. So it doesn't matter. It's just y is a little bit smaller to work with, and that's why we do it. Okay? Now, let me ask you this, because you guys know the next step. How do you find an inverse? Think of the definition we wrote down. How do you find the inverse? You flip what around? Yeah, you switch x and y. So if I switch an x and y, what would my new equation say? What would my new equation say? No? I switch x and y. That's all I do. Switch the x coordinate and the y coordinate. X equals 2y minus 6. I switched the x and y. So everybody write that down. That's step 2. Step 2. Switch x and y. Okay? Step 2. Switch x and y. Okay, step 3. Y equals 2x minus 6, and then x equals 2y minus 6. Okay. What do you think we need to do next? Step 3. Solve the equation for y, because we want to graph, okay? So that's step 3. Solve for y. So we're going to solve for y. What are we going to do to solve this equation for y, you guys? Before we divide by 2, we have to do something else. We've got to add 6. Y by itself, we got to do the addition and subtraction part first. We got to do the opposite order of operation. So x plus 6 equals 2y if I do that. Well, this is stuff you're supposed to learn a long time ago. Just do it right now, because you're going in the reverse order. Okay, what am I going to do now to get by itself? You add 6 to both sides. Yeah. See, if I add 6 to this side, negative 6 plus 6, if I combine like terms, see, I've got to combine like terms out of those terms. Like are negative 6, right? I add them, I get 0. But on the other side, I have x and 6, and they're not like terms, so I can't actually put them together. I just can write x plus 6. No, because 6x means 6 times x. What am I doing right here? I'm adding. So it's x plus 6. Okay, this is what I do, you guys. Divide by 2. What would I get? Those cancel out. And I'm going to rewrite, you guys, I'm going to put the y over here. That y is going to go over here. Y equals x. And by the way, I'm going to divide 2 into both terms, right? This is 1x, so I'm going to write 1/2 x. And 6 divided by 2 is what, you guys? 3. Okay, I'm ready for step 4. You guys ready for step 4? You guys, because that's 1x. 1x divided by 2 is the same thing as 1/2 x. I'm dividing 2 into it. 2 doesn't go into 1 evenly, so we just leave it as a fraction, 1 over 2. But 2 goes into 6 3 times, so I can write plus 3 right there. Okay, step 4. Okay, replace y with f inverse of x. That's the next step. It's just opposite of what we did at the bottom. So f inverse of x equals 1/2 x plus 3. Okay, if you wrote those notes down, you should be ready for Sage and Scribe. Okay, here's this example right here. Let's see how you did it on the Sage and Scribe. Okay, first of all, I replace f with y. Then to find the inverse, what do? Switch x and y. Then I solve for y. I'm going to minus 4 from both sides. That's going to give me x minus 4 equals 1/2 y. And then you guys, think of it as I've got to get rid of that 1/2 that's being times by y. What's the opposite of timesing by 1/2? Timesing by the reciprocal. Some of you guys thought of it as dividing. You can divide it by 1/2, but it's the same thing as timesing by the reciprocal. What's the reciprocal of 1/2? 2. If I times both sides of this function by 2, these 2's cancel out, and I'm going to put the y on the left side. Distribute the 2, you're going to get 2x minus 8. That's what you should have gotten. I had to times the 2 I had to distribute the 2. 2 times x and 2 times 4. Hey, you guys, some people are trying to ask some questions to understand. You guys are talking way too loud. Okay. You guys, I could have divided it by 1/2, but look. Let me show you what 1/2 divided by 1/2 is. It's the same thing. You guys remember when you learned how to divide a fraction by a fraction? You take the top fraction and you times it by the reciprocal of the bottom fraction. 1 times 2 is 2. 2 times 1 is 2. 2 over 2 is equal to 1. Well, it cancels it out on this side. But basically what it was doing, it's the same thing as timesing it by 2. Dividing by 1/2 is the same thing as timesing by 2. Just, you guys, whenever you have a fraction like this, times by the reciprocal. It's easier. Flip it over, flip the fraction over, and times it. Say that again. 2 over 2 is equal to 1. Okay? Okay, now, I'm not done with this problem. What's my last step, you guys? What's my last step? Yeah, changing the y to f inverse of x. And that should be my answer. All right, now, you guys, the curriculum, and we're going to have to spend a couple days on it, so I think that's all we're going to do on this today. I'm going to give you the assignment, but we're going to only do parts of it today.